Hello everyone and welcome to tutorial number 31 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. In the last tutorial I discussed about nested interfaces, and after that I discussed about the extending interface. So if you are interested in learning these concepts, you can go and watch tutorial number 30. So in this tutorial, I'm going to be talking about exception handling, which is a very important concept in Java. So let's get started. So first of all, what is an exception? Okay, exception, it is a kind of a runtime error. Okay, so whatever error we are going to encounter when a program is under execution, when the program is running, that is a exception. Okay, so mostly it can be handled using try catch block. Okay, so here for handling the exceptions we need to create a try block, then after that we need to create a catch block. Okay, so usually we handle it using try catch. Okay, but however it is not mandatory to write the catch block. Okay, but you can even write the finally block after try. But usually, if you want to handle exceptions, it is done using try catch. But the catch, it is not mandatory. But however, if you need to either write catch or finally after try. Okay, that thing is mandatory. That is up to you whether you want to write the catch block or whether you want to write the finally block. But out of these two blocks, any one of these blocks is mandatory. Okay, so these things will be more clear when I use the IDE. So now these are the keywords which we use in this particular concept. We can use the try is also keyword, catch, finally, throw and throws. Okay, now don't get confused by these two keywords. Okay, both of these keywords are not the same. All right, this throw keyword is different from throws keyword. And when I will be discussing about this more detail in this tutorial itself, that what is the difference between throw and throws. All right, then after that, what is the code which you're going to write in the try block. Okay, the code which has the possibility of causing a runtime error, like for example let us say division by zero. Okay, or let us say like we are trying to open a file which does not exist. Okay, so these are the possible code which is which has the possibility of causing a runtime error. Okay, in that situation we are going to write this particular code, okay, suspicious code, inside the try block. Okay, after that inside the catch block we are going to write the handling code. Okay, exception handling code, we are going to write it inside the catch block. And one thing which you need to remember is, the finally block, it is always executed, no matter what. Okay, whether the exception is caught or whether the exception is not caught, that doesn't matter for that program. That doesn't matter for the compiler. The program, it is always going to execute the finally block. Okay, so these are the things which you need to keep in mind. So then after that, I'm going to talk about the types of exceptions. Okay, so there are usually two types of exceptions. One is handled exception. Okay, one is unhandled exception, or we can even call it as caught exceptions and uncaught exceptions. Okay, so caught exceptions are those exceptions which we need to write in a try catch block, and it is mandatory. Okay, or you need to use the throws keyword. Okay, so you will look into all those things very soon. Okay, however, for the uncaught exceptions, okay, you don't need to necessarily write it inside the try catch block, or you don't need to use the throws keyword. Okay, so now one thing which you need to keep in mind is that the base class of the exception class, it is throwable. Okay, the exception class itself, it is a child class. Okay, it is not the base class. It is the base class of all the exceptions, but however it itself derives from the throwable class. Okay, so there are two classes in Java. One is the exception class, which I said earlier, it is going to inherit from throwable, and another is the runtime exception, okay, which is going to extend from exception. But however, this runtime exceptions, they are different. Okay, these are uncaught exceptions. We don't need to necessarily write them inside a try catch block. Okay, there is one another class in Java which is known as error class. Okay, if you have noticed or watched one of my previous tutorials, okay, when I used the IDE, I think it was in the tutorial when I talked about recursion, okay, using the IDE. So in that tutorial, I showed you about the stack overflow error. Okay, so that stack overflow error, that class, it is going to inherit from this error class. All right. Then after that we have uncaught exceptions. As is, told you just now. Okay, these exceptions, like for example, we have arithmetic exception. Okay, or any other subclass of runtime exception. Even arithmetic exception, it is a subclass of runtime exception only. Okay, or any other subclass of runtime exception. These are uncaught exceptions, which means we don't need to enclose. It is not mandatory to enclose these. Code which is going to throw these exceptions inside a try catch block. Okay, it is not mandatory, it is completely optional. It is up to you, whether you want to write them inside a try catch. And but however, that doesn't mean that you should not write them in a try catch. Okay, it is completely optional. You can definitely write them in a try catch block. It is not going to give you any errors. Okay, so but it is completely optional, and these are unhandled or uncaught exceptions, as I told you earlier itself, and it is not mandatory to handle them. Handle them means write the try catch block. Okay, so it is not mandatory. Then try and catch block, as I told you earlier itself, try and catch block, they are the basis, they form the basis for the exceptions. Okay, so, if you want to, but where are we going to use this try and catch block? Whenever we are going to, manually handle an exception. Okay. If you want to manually handle a particular exception, let us say, you want to, handle a, input output exception, like as I said earlier. Okay. You're trying to open a file which does not exist in the first place. Okay, in that case, it is going to throw a IO exception. So if you want to handle that particular exception, then for that purpose we can use the try catch block. And there is another feature of the try catch block is that it is going to prevent the program from terminating. Okay, if you don't use the try catch block, the program will terminate, at the very point when it encounters an exception. Okay, this is one very important concept which you need to keep in mind. If you don't use try catch block and the program it encounters a runtime error or runtime exception, okay, like like I told you, IO exception, input output exception, or something like that. If it encounters an exception during the runtime, then the program, it will terminate, it will stop working. Okay, so because of that reason you need to use this try catch block. If you don't use it, it will terminate. Another thing is, this catch block, it cannot exist without try. Okay, so that thing also you need to keep in mind. This catch, it cannot be standalone. It must be preceded by the try block. Okay, and as I said earlier itself, either you need to write a catch block or finally block if try block is defined. Okay, if try block is defined, it should be either followed by a finally block or a catch block. All right. Then after that, another thing we have is multiple catch blocks. So multiple catch blocks means, that doesn't mean that we are going to create multiple try block. No, that's not the case. We are going to create exactly one try block. Okay, like here I have not shown you the exact example, but before this catch block, okay, there will be a try block. Okay, so just assume that there is a try block before this catch statement. So after this, okay, only one try block is there. Then after that, we have this two catch blocks. So one catch block is arithmetic exception and another catch block is runtime exception. And one additional thing, which I would like to add is as I said earlier, this arithmetic exception, it is a subclass of runtime exception. Okay, so that is what I talked about in the third point. Subclasses must always, be written before the superclass. Okay, why the thing is like this is because if I, interchange these two catch blocks, okay, it is going to cause a error. It is going to cause a compile time error. The reason why is because it is going to show that this code is unreachable code. Okay, why? Because runtime exception, okay, this, sorry, not runtime, this arithmetic exception, it is a kind of runtime exception, right? Because this arithmetic exception, it is extending from runtime exception. So arithmetic exception, it is a kind of runtime exception. So this runtime exception, it can handle this as well. So if I write this particular statement after this particular statement, it will give an error because all arithmetic exceptions are caught by this particular catch block. Okay, so because of this reason, this particular catch block will not execute. Okay, so this may seem a little bit confusing right now. This will be more clear when I use the IDE, because right now I'm not using the IDE. It may be seem a little bit confusing, but bear with me, and I will show you how exactly it works using the IDE. All right, so the next thing is nested try block. So, whenever you're writing a try, block within a try catch block, okay, so that is nested try block, okay, and we have seen this nested statement a lot of times. We have seen it in nested if, okay, nested switch, nested interface, nested class, etc. So you already know, how this is going to work, okay. And one additional thing is that if inner try catch block, if inner try catch block, if the exception is not handled by the inner try catch block, then the exception, it may be handled by the outer catch block. Okay, so this is something new. Okay, so this thing also you need to keep in mind. We will look at all those things when I use the IDE, so don't worry, just remember those concepts. Then after that we have the throw keyword. Okay, now we are coming to something different. Okay, till now we have seen what how we are going to handle a particular exceptions like using try block or catch block. Okay, but now we are going to manually throw an exception, manually or explicitly throw an exception. For that purpose we are going to use the throw keyword. Okay, so this is used for explicitly throwing an exception, and this particular statement, it is written either inside a body of a method or a constructor. Okay, so that is where we are going to use this obviously. Now let us go to the first point. Okay, throwable instance. So after the throw keyword, you need to write the you need to actually throw the instance. Instance means object. You need to throw the object of those classes which are deriving from throwable class. Okay, throwable or exception class, because exception, it is a subclass of throwable. So either you can obviously you can throw the object of those class which are deriving from throwable or exceptions. Okay, so that means I cannot create throw a string here. I cannot throw a boolean variable or something like that. That is not allowed. Okay, i I cannot throw new object here. That is not allowed. Okay, because as I said earlier, object, it is the base class of throwable, and it is not deriving from throwable, right? Throwable is deriving from object. Object is not deriving from throwable, so you cannot throw an object here. Okay, so you need to write only those. You need to throw only the object of those classes which are inheriting from the throwable class. Okay, so that is the syntax of this particular keyword, particular statement. Then after that we have the throws keyword. Now this throw keyword, as I said earlier, this is the syntax which we use, and in the throws keyword, this is the syntax which we are using. Look at the second statement. public void Java throws exception. Okay, so this is the definition of the method public void Java, and after this parenthesis we are writing throws exception. Okay, so what do I mean by that? I am telling the compiler, I'm telling the program that it is possible that this method, it might throw an exception. Okay, it is possible that this method might throw it may have some suspicious code. Okay, so I am informing the compiler, I'm informing the program about it. And if you are using this particular throws exception, then there is no need to write try catch block. Okay, because this exception class, okay, this exception class, it is the base class of all exceptions in the Java programming language. Okay, so you don't need to write try catch block. Okay, because it can handle almost all exceptions. So as let us recap this very quickly. This throw keywords, it is written beside the meta declaration as I have shown you here. Okay, and if you are using this throws exception, then it is not necessary to write try catch block. And there is one additional thing which I like to add. Me personally, I like to always write this throws exception, because exception is the super class of all exceptions. But however, that doesn't mean that only this syntax is allowed. You can write IO exception here, you can write arithmetic exception here, you can write runtime exception here. That is totally up to you. And you can write even more than one exception here. Okay, throws, let us say IO exception we have. Okay, we can have a class not found exception. Then that these two exceptions, they will be separated by commas. Okay, so then after that we have the finally keyword. So the code which I'm writing inside the finally keyword, it is always going to get executed no matter what. As I told you earlier itself, whether the function or the method, it is going to throw an exception or whether it is not going to throw an exception. Okay, obviously the code is going to be written in the try block. So whether it is going to throw an exception or not, that is not, the compiler or the program, that is not going to consider that. It is always going to execute the code which is written inside the finally block. Like for example, the like we have a file, a code which we can use for closing a particular file. Then we can write that particular code inside the finally block. Okay, so because we know for sure that the code written in the finally block, it will always get executed. So because of that reason, we can always write this code inside the finally block. And another thing which you need to remember is this block is completely optional. Okay, so you may write it, you may not write it, that is up to you. But it all depends on the logic of the program, what you are writing. If the code demands that you need to write the finally block, then it is always advisory to write the finally block. However, if it does not demand it, then it is up to you whether you want to use it or not. Okay, but you need to remember that the code written in the finally block will always and always get executed. So you should not write any suspicious code inside this finally block. As I said earlier, any suspicious code which has the possibility of throwing a runtime error, okay, or runtime exception, or any exception, I mean, you should always write these code in the try block. Okay, always and always write them in the try block, because otherwise the compiler, it is going to start complaining. Okay, and then you need to fix the error. Okay, so the program will not execute. Then after that, okay, I think that's all I'm going to talk about in this particular tutorial. Okay, if you have any kind of doubts or any kind of questions, then don't hesitate to post in the comment section below, and I will get back to you when I can. And if you liked this particular tutorial, then don't forget to like, share and subscribe, and I'll see you in the next tutorial. So till then, bye.